Happy Friday, everyone, and welcome back to day 3 of the Cyberbot Educator Workshop with Python and the Microbit. As usual, here are the links, and I'll go ahead and paste this in. I forgot to mention that during previous times, so we've got the mobile device QR code and the bit.ly shortened one for easy typing if you're watching this on YouTube, but also on the YouTube post in the description, you'll see this link right here, and you can just click it to go to the presentation. Let's see here. So chat. Paste. Okay, before we get started, I would like to mention that we have a couple of workshops upcoming. The ActivityBot 360 is coming up very soon, so it is closed. We won't have time to ship out an ActivityBot to you if you wanted to attend that one. And as you know, we always put those on YouTube, so you're more than welcome to watch, get an ActivityBot and try it on your own later if you want to, or if you're so inclined. But more importantly, we have this one coming up, Electronics with Python and the Microbit. So if any of you are looking for some additional pre-engineering material for your students, this is a really great little set of chapters. As an example, let's take a look at this. I forgot to link this this image, unfortunately. So we'll go to learn.parallax.com and then go down to Python, and you'll see Cyberbot, but there's also what's a microcontroller with the Microbit and cybersecurity, which we'll be talking about. If we go to what's a microcontroller with the Microbit, there. Now, if you click this, you'll be able to go straight to it. So basically, if you click this image, the link appears and you can follow it. Okay, so taking a look at it, one of the things that we were experimenting with here was making additional use of graphic and video techniques at our disposal. And so you'll see things in here because electronics can be a challenging subject. And so one of the things that we're trying to do is incorporate anything that we can with video to help basically convey ideas. And we also have this, anytime you see an animation like this, there is a version, an MP4 version that you can play back and pause and move forward and backward and so on. So if you wanted to, for example, stop and talk a little bit more about row numbers with your students, or talk a little bit more about how the intersection of a row number and a column letter can be given in a certain kind of notation. These are all things that are built into this electronics course in the hopes of making it easier, because electronics, like real electronics, can be kind of challenging. Another thing about it is that we are we're doing a lot with setting up examples for students to follow along, and I just landed on one that I don't think. Let's see, measure voltage, script and tests. Here we are. Okay, so this one right here is another example of learning a key electrical concept, which is that basically if you have electric current flowing through some devices connected end to end, that you can measure the number of volts applied to the circuit. And then you can go and look at each component and find out that the number of volts on each component is this, it will add up to the number of volts applied to the series circuit. And so here we have a video clip where first we're taking a measurement of the total voltage across the circuit. And this is a software equivalent of an actual testing device called a voltmeter. And so the microbit is actually sending data to cyberscope.parallax.com, which is where we have a virtual, well, it's not virtual because it's actually, you're actually using it. It's a test bench software that accompanies the microbit. And so then we go and measure the resistance across the resistor, and that's 1.2. And then across the light emitting diode, which is 2.06. And coming back to where we took the voltage measurement, those two values do in fact add up to 3.26 volts. And notice also that we have even schematics of where the probes are applied, and that schematic even updates as we're measuring different spots. Like when we switch over to measuring across just the resistor, we show the schematic equivalent of that. So there's a lot of stuff built in here. One last thing about it is that it's got this really cool and awesome, by the way, this is the way to get back to any given bookshelf. You'll find it below the contents of the chapter. And so like, by the way, we've got resistance, measurement units, current, Ohm's law, all kinds of basic fundamental electrical stuff here. Moving on further into the chapter, like when we get to servo position, we can actually use the oscilloscope portion of the Cyberscope application, web application, to measure the signals that are sent to the servo, even though they are basically too rapid for the eye to discern. We can actually graph fluctuations in voltage. In this case, there's a certain amount of time that the signal stays high. This is stuff that I talked about with regards to the, talked about how the control signals go to servos on Wednesday. And so here the students actually get to take measurements. And if I back up, and so we also use graphics to show that these little high on signals last certain amounts of time, and those amounts of time, in the case of a standard servo, instead of mapping to speed and direction, they map to holding a certain position in the case of this servo with a 180-degree range of motion. So these are little examples of, and previously they used the same oscilloscope equipment to measure a blinking light, so that everybody's very clear that when a light turns on, you see this high signal. It might just last a much longer amount of time than the high signals for servos. So we're doing everything we can to put as much electronics understanding into a few short chapters. And so this kit, we're going to be doing a workshop on it October 24th, 26th, and 28th. It's just like this one. It's a series of 3 2-hour workshops. And so if you're interested, I believe we have some openings still, so please do sign up.
I had a question about that. So I was just looking at registering, and since I already have a Parallax kit that you guys send,
yes.
So it says that would mean I don't qualify, but I still need to register, right? So how do I get past that form?
Stephanie, can you help me out with that? Because I don't know anything about not qualifying. Stephanie may have stepped away from her computer. I don't think you not qualify. You would only not qualify if you've already taken this particular class.
Oh, okay. I thought since I already have the microbit, but okay.
Yeah, no.
If you already have a microbit on the application form for this class, you can indicate whether or not you have the microbit. Since you already have it from the robot, it's really helpful to us to send you the electronics kit without the microbit because they're in short supply. And then
Yes.
stretch the supply. So, but there is a place on the application to indicate whether or not you need us to send them the microbit. So
Oh, okay, maybe it's just on the next page because it wouldn't let me go until I clicked yes. Okay.
oh yeah, there's the yes is whether or not you're in the US and you're a teacher and things like that.
Okay, thanks.
Thank you.
Sure thing. Yeah. Okay, good. Yeah, so no rules changed then, Stephanie. It's we're still letting folks in. Yeah, we're not limiting to one course, but as Stephanie said, it does help us out a great deal if you're able to make use of your Cyberbots microbit for this kit as well. All right, moving along. As always, feel free to ask questions. Just unmute yourself. Today we'll be talking about navigation with infrared and making our robot navigate with infrared. We'll be doing, we'll talk about also some additional projects and cybersecurity topics you can cover with the Cyberbot Robot Kit, and educational resources for students and teachers, and classroom implementation, including where to purchase the Cyberbot and other kits. Okay, I couldn't think of any sample questions for today. So does anybody have any additional questions before we get going? All right, well, here we go. On to infrared light navigation with the Cyberbot.
Well, before we do that, I just want to know, did everyone have success with what you tried?
Oh, that's a good question. Have one head nod, yes.
Did everybody actually do their homework, or were you just saving it for the weekend?
I did say optional, in all
It doesn't
fairness,
say
because
optional,
I
okay.
know that you guys are super busy during the week. So
Yeah.
I kind of cringe whenever I throw out homework that's in between two workshop sessions. And thank you, Randy.
That's how
glad
we
it
know
worked.
you. That's how we know you're not in the classroom, Andy, because those of us that are know that we never say words like optional.
Yeah, I didn't get to do any of the homework, but I did bring the robot into my class to demonstrate. So every class got to see the little whiskers work, and
Oh,
I told them
fantastic.
all the mistakes that I made while I was trying to build it. So they got to see it at least.
That's great. How did that go over?
Oh, they thought it was amazing. They had so many questions about how it worked. Could you make it go faster, slower? And we did the very high-tech test before starting, where I tell them, very important, cross your fingers before we turn it on. As you know, top of the line programmer, first thing you learn, right? So they thought it was great. So
That's great.
Oh, yes. Yes, thank you indeed. That's fantastic. All right.
I'm done interrupting. I'll mute myself now.
Okay.
I have a question.
Oh, yes, Justin, please go ahead.
We've purchased enough robots for our school district to have a program of study, but we're wanting to have like flexibility with this platform. So other things that are, we have other things with our Arduino kits.
Uh-huh.
We be able to integrate a lot of that stuff into the Cyberbot probably.
Probably. It's going to vary. Let me switch over to my screen here, or rather to the video of the Cyberbot. Okay, so let's see if we can get a closer look at the Cyberbot. So there's a number of items that go with the Arduino, especially if you are using our Arduino robot. All those items also work with the Cyberbot, or almost all. Some of the other items that are mainly open and common, but aren't necessarily used with our robot. Some of those will work with connections here. You'll have to port the example code. Other of those will work with these connections down here. So there's the microbit and the propeller that's right there underneath the breadboard. Each have their own sets of strengths and weaknesses, and so sometimes you'll find yourself using these connections for those circuity things. Other times you might find that there's already an application supported by the microbit, in which case you can plug in here, because these map directly to microbit IO pins. And so you can actually plug the wires and right into these as well. So those two things combined should help a lot. And I will be showing you a little bit later during this session some of the peripherals that you can use, and some of those that you may already have that you'd want to use with the Cyberbot robot. How's that sound?
That sounds great.
Okay. And then do chime in if after the projects section you don't see something that you're interested in, or if you have a specific favorite that you want to find out about, go ahead and call it out now. Either way is fine.
All right, we're good.
All righty. So here is the infrared object detection in action. So instead of bumping into the box or bumping into the wall, it instead looked like it bumped into the box about 4 inches away, and likewise with the wall. And so that's often preferred, like especially if you're in a maze, it's a lot easier to veer away from walls if you can see those walls without touching them. There's also other applications, like you can follow a stripe, a broad stripe painted on the ground. I use flashing tape from construction, usually Home Depot, Lowe's, those kind of places have some really wide flashing tape that you can lay down on several pieces of poster board and follow those as a track. You're looking usually at some kind of 6-inch wide black vinyl tape is what's preferred if you're going to lay down a track like that. Here we have the infrared chapter, and I'll just start by going there. And so this is that same video. It kind of helps convey an understanding of what's happening. Then we talk about how an infrared receiver can, or how you can mount an infrared light emitting diode onto your robot, and it will send infrared light that you can't actually see out. And then that light will either bounce off an obstacle and come back to an infrared receiver, or it'll go off into infinity and not come back to the infrared receiver. That infrared receiver, like a whisker, will either send a high or low signal, which translates into a 1 or a 0 inside the microbit. And by the way, this is the infrared LED that's in the old handheld TV remotes. And this is the infrared receiver that is inside old television sets that are controlled by a remote, where you have to point the remote at the TV. These days, they've switched over to various radio ways of controlling TVs. And so a little bit more about infrared. Here we explain the visible light spectrum, and then off beyond or below red is the infrared light spectrum. And this was introduced in the visible light navigation, which I talked about at the tail end of Wednesday's session. And incidentally, so here is the idea behind a TV remote, and it actually shows here's the infrared LED, it's inside the TV remote, here's the receiver, it's inside the TV. And there's two levels of rapid on-off flashing that go with a TV remote. One level is the fact that it has to turn its light on and off at 38,000 times a second, or 38 kilohertz, for the sensor to even see it. But beyond that, it has to flicker it for a little while, then stop for a little while, then flicker it for a little while, then stop for a little while. And that is how it sends out its binary 1, which is this long while flickering, and this binary 0, which is a shorter while flickering. And in many cases, and darn it, I think I forgot to make sure I had a remote nearby. In many cases, what you can do is point one of these old remotes at your document camera or cell phone, and you'll be able to see that flickering light at the front of the TV remote, even though if you just look straight into it, you can't see it. Okay, so next up, I'll go ahead and paste in this link. We'll have everybody gather their parts. But actually, hold up for just a second. I want to talk first about these little clear light emitting diodes. You'll see 2 red light emitting diodes in your kit and 2 clear light emitting diodes. And then you'll see things that look like clear light emitting diodes, but they have a flatter dome top. So this is a very rounded dome top on our infrared light emitting diode, our clear infrared light emitting diode. But there's another clear plastic case that has a flatter top. So make sure to use the infrared light emitting diode, or when you're grabbing parts, make sure that it's about the same shape and size as the red light emitting diode. Let me switch over to this screen so you can see what I'm talking about. Okay, so dumping my bag of parts back into the bowl. And I'm going to grab a red light emitting diode. An infrared light emitting diode. And a photo transistor from the light navigation chapter. And hopefully, there we go. So hopefully it's now fairly visible that we have 2 light emitting diodes that are of very similar shape, and that this photo transistor has a shorter plastic case. So find the red ones just as a reference, and then make sure that the clear one you get is almost exactly the same shape as the red one. And so we're going to grab these parts. I'll check and see if I've got a better image for you in my slides. Yeah, I think that takes up more real estate. So I'll leave that out. You're going to have 4 resistors, 2 that are 220 ohm. That's red, red, brown. two that are 2000 ohms or 2 kilo ohms. That's red, black, red. And then these are your infrared receivers, infrared LEDs. And then these are little plastic tubes that we'll be putting our infrared LED into so that it doesn't scatter light backwards towards this. We want the light to go out the front and bounce off something and come back towards these guys, not from the source directly. So go ahead and grab all these
Hey,
parts.
Andy, is
Yes.
that the same ones that we used last time? The same resistors?
Well, it's the same red, red, brown 220 ohm resistors. Those are the same resistors you connected to your IO pins. It's probably P5 and P7 or something like that. But the other two resistors that were used with whiskers were brown, black, red. So these resistors are red, black, red, or brown, black, orange. I'm sorry, 10 kilo ohm. That was with the whiskers. These are smaller resistors. They're red, black, red. Your robot will be too nearsighted if you try to use the 10 kilo ohm. These are about a fifth of the size. They resist the current of, they resist electric current flow by 1/5 of what those 10 kilo ohm resistors you used during the whisker activity.
Okay, thank you.
Certainly. Thank you for asking. Okay, so what I'm doing is fishing my parts out while you guys are hopefully doing the same. Now, the instructions in the textbook are pretty good, but what I'm going to do just to save us time is really walk everybody through this step by step. Because troubleshooting is preferable at this point. It's good to have the students get stuck and have to fix their mistakes. But in a 2-hour session, I don't want to do that to all of you. Okay, so can everybody see the parts well enough, either on the web page I texted you or on my screen? Okay, excellent. Please give me a thumbs up once you've got all your parts gathered. Good job, Ellen. Thank you, Marcel. Thank you, Randy. Excellent. Justin, excellent. Can anybody give me a thumbs down if they need more time? Thank you, WB.
We got a thumbs up from Susan, but I think I'm the only one who can see it.
Oh, okay.
So thought I'd pass it on.
Thank
Well,
you, Stephanie and Susan. Okay, so we'll jump to the part where you go ahead and just stop me if I'm moving too fast. All right, so now that we have all these parts, and we know the difference between the phototransistor and the infrared LED, light emitting diode, the next thing that we're going to do is take the light emitting diode, the LED, and put it through, there's going to be an opening on this end, and then a little flat surface on this end. And the flat surface on this end has 2 holes in it. And so you'll take the LED and take those 2 pins all the way down, and then you'll see the 2 holes way in the bottom, and you'll put the LED through those 2 holes, and it will sink in part way into this. And once it does, you can put the little end cap on there. And when we're done, it's going to look like this. Also,
I'm not seeing what it looks like when we're done.
oh. It looks like this lower one right here.
Okay.
Thanks. Okay, so this is the bottom with the 2 holes. So we want to go in this deeper part with our light emitting diode. So our pins are going to go in there and then through the 2 holes. And on the bottom, you'll see a little plus right there. Oh, I'm sorry, right there. So that plus, you can put the longer pin through that little plus sign, through the hole that's closer to the plus sign.
I had a question. So for these who are making the sensors and snapping them in, now, is it possible to take them apart again? So I'm just thinking, if I'm teaching a student and I teach multiple classes, would I be able to take it apart and so the next class show them, or is it?
I don't know. Let me try taking one apart after I put
I
it
don't want to
together.
break it right now.
Yeah. Yeah. So I put them all the way in, and
Yes, if you use the screwdriver, you can.
okay. So it sounds like if you pull on it a little bit or use a screw, how do you use a screwdriver to get in there? Do you just kind of put the edge on the seam? Oh, there we go. I kind of pushed and it sunk in. There.
Oh,
Yeah.
thank you.
Yeah, it works. Thank you. And we want it to look like that when it's done. And so we'll do that for both of them. Trying to get, now make sure that each wire passes through a separate hole. These are 2 holes right here. The wires should absolutely not be going through it. You do not want a pair of wires to pass through a single hole because they'll short against each other and the system won't work if you do that. Okay. So there is my second infrared LED assembly. And I forgot to get my resistors. Looks like I made a mistake. I see a red, red, red. Want red, red, brown. And then red, black, red. Okay. All right. So next up, this part might be slightly painful, but I really would prefer that we not. I'll talk a little bit about it first because it is possible to add them to your whiskers circuit. But if you do that, you'll want to put electrical tape over the parts of the whiskers circuit that could end up touching the parts of the infrared circuit. So we'll go ahead and leave that for if you want to try it with your students. But just remember, you'll want to put electrical tape around this part of the whisker because we'll have our infrared parts built right here and right here. And if the whisker happens to pass too far, it might end up pressing up against those electrical parts and could even damage them. So again, electrical tape around the whisker here and there if you decide to do this. However, my recommendation would be to just take everything off your Cyberbot breadboard, including the whiskers. So take the screwdriver, and you only need to loosen those screws just a tad to get them back out. And then make sure to tighten them back down. Again, this is all covered in step-by-step instructions with little red check marks in the textbook, but I'm wanting to make sure that we all kind of have success on as close to all of us have success on the first try as possible. Okay, so again, go ahead and jump in if you need me to stop or slow down. So the next thing we're going to do is we're going to build this circuit, and we'll start by placing the light emitting diodes, the infrared light emitting diodes. We're going to have the longer, we're going to put both the light emitting diodes at the very topmost pair of white sockets, top rightmost pair of white sockets, and the top and the bottom rightmost pair of white sockets. And the longer pin will have to be in the very top socket and in the second from the bottom set, basically in the top socket of where they go for each of those light emitting diodes. So if you can see on my screen, see how I have the longer pin topwards? I'm going to put it in those two sockets right there. Just give me a shout if you want me to repeat any of this. Again, I have it oriented so that the longer pin is toward the top of the screen, and these are going into the bottom right pair of sockets. And again, we have our longer pin right there. And then this is also the longer pin right there. Okay, next up, I should really give you guys this in case you want to build it straight from the diagram. Copy. Paste. Okay, so that is the page we're working from. Okay, and so we're gonna go one column leftward from the light emitting diodes. And we'll put the pins in one row immediately down from the light emitting diode. So light emitting diode pin, and then 3 IR receiver pins. Can everybody see that okay? A reminder to make sure the pins, that all pins that you plug in sink in about 1/4 inch. Okay, so we want to be one row, we want to be the next row up from the 2 infrared LED pins. So rows 1, 2, and then 3, 4, 5 on the bottom would be the would be where the lower of the 2 infrared receivers gets plugged in. I'm going to bend these back. Don't do this part if you're just watching along. I'm just bending them back so you can see where the pins go, and then I'll rebend them forward. Leave yours straight up and down, please. How is that visibility wise?
Very clear,
Okay, excellent.
in my opinion.
All right, I'm going to bend these back up to their proper vertical arrangement. And the next thing we need to do is connect our brown, black, or red, black, red resistors, the 2 kilo ohm resistors. They're being connected to the LEDs. So that's going to be this schematic here, P14, LED plus pin, or the LED longer pin to P14. And likewise, the LED longer pin to P1. So that's from, pardon me, 2K, red, black, red, from LED longer pin row to P1, and from LED longer pin row up top to P14. Make sure you're using the red, black, red resistors for this. Okay, so that's the same row as the LED long pin. And then I'm going one socket down from the top in the black column where it has P15, P14, P13, et cetera, down to P1, P0 labeled. So P14 to same row as long pin. Okay, next up, the shorter pin needs to be connected to it looks like we don't have enough wires for this. I'm using blue wires to connect the LEDs to ground. And I didn't see those wires in the picture. So I know you grabbed 2 black wires already, but grab 2 extra blue wires. The reason I grabbed blue wires is because in a distance sensing activity that we haven't yet published, those go to the D to A ports right here. But for now, we're just going to put them into ground right next to the D to A ports. So we'll take one wire and put it in. Make sure it goes into GND. not D/A0. So here is D/A0. Here is GND. So make sure it goes in the GND socket. And let's see, we connect the rightmost GND socket to the shorter pin. And then we're also going to go one over and connect that GND socket to the shorter pin of the upper infrared LED. There, I think you can see everything now. And looks like I'm still missing a resistor. Again, that resistor goes to the shorter pin of the LED on the bottom. And on the bottom, it goes to P1. Okay, then our 220 ohm, our red, brown resistors are going from P13. The first one goes from P13 to the bottommost pin of the IR receiver. That's 5 rows down. So here is bottommost pin of the IR receiver. Make sure it sinks in. Make sure it sinks in about 1/4 of an inch. Be very careful to double check your socket bomb sites. Then the bottommost, basically 3 rows up, you'll put your other 220 ohm resistor to the bottommost pin of the IR receiver row, and then into P2. Okay, we still have to add power to our infrared receivers. So that is going to be 5V to the 3rd row down. That's the top pin of the top IR receiver. There is a 5V socket. Top pin of the IR receiver. Pull that back by 1 row, maybe it'll be more visible. There we go. And then 5V to the top pin of the lower IR receiver. So here's another 5V socket right there. And then down to the 5th row from the bottom. There we go. That's the 5th. Let's see, 1, 2, 3, 4, 5. Yeah, that's the 5th row from the bottom. Then for the electrical pressure to power the infrared receivers, we also need to give their middle pins, the middle pin of each infrared receiver, a connection from that middle pin to GND. So for the lower one, that is going to be the 4th row up. And then that jumps over to GND. One of the black sockets labeled GND along the bottom. And then the middle pin of the upper infrared receiver. There we go. That's the fourth row down from the top, fourth white row down from the top. Plug it in there. And then bring that one down to a GND connection. I hope that was helpful. I feel like it wasn't quite the way I imagined it in terms of clarity. I think I should do it in a different order next time. See if I can arrange these so that everything's visible. Okay, how's everybody doing? Make sure, let's go ahead and check. That's the nice thing about these drawings.
I've got a comment. I have a student with deformed hands who would love to do electronics, but is limited by the dexterity and finger size. What do you think about using plastic anti-stat tweezers? I think that's amazing, actually.
Yeah, and they don't even need to be anti-stat. You know, the idea would be to just turn the power off. And I don't really think that, I mean, there's always a slight possibility that static will play a role with those IR receivers. I just, you know, we don't have a lot of history of things being static zapped. So yeah, so here we are with, now honestly, when I'm building circuits, I am constantly, you know, going in with a pair of pliers and, you know, inserting and using those to insert. It works a lot better unless you have bent pliers like these are actually slightly bent, unfortunately.
Do those pliers ever come with a coating with an non-conductive coating on the grips?
Well, yeah, non-conductive coatings on the grips are kind of the most common way they come.
The other end.
Well, I don't think you need them on the other end. Basically, if you're right now, my hands are not, the static in my hands are not conducting to the metal part here.
Okay. I guess with the metal tools of any kind, it would be easier to accidentally bridge from component to component on their metal leads. So
yeah, and you know, that being the case, you know, I would say unplug the battery, unplug the microbit, those, and that's a good practice anyhow.
That's true.
Yeah, and then you're okay. Ideally, if you want to really go for the electronics training, you know, have an anti-static mat and an anti-static bracelet. Those are fair game. It's not a kind of equipment that we sell, but there are you know, electronics outlets like DigiKey and Mouser are going to carry those. And you basically plug the mat into the wall and it gives you a ground connection. There are versions of these pliers that actually have a bend in them. They might be really useful for this kind of work. And
Can you just move the wires a bit on your, so I can see where the black and the blue, they're really close together and I'm not sure I got mine in the right place.
yeah, so here, let me go back to the, I'm sorry about that.
Because
How
it seemed
about
like the
now?
drawing was a little different, so I'm just trying to.
Yeah, is that the drawing is a little bit different because I conveniently shortened the wires as I drew this. Or actually somebody named Courtney drew this. But yeah, that we hopefully make it nice and clear here. Can you see now how they go?
Yeah, I can see that. Can you show your one though that you have
Okay,
built?
let me try to get these guys
Yeah, that's
separated.
better.
Oh.
that works. Thanks.
Oh, excellent,
Yeah, it was
excellent.
just the blue and background popping each other. Okay, thanks.
There, how's that? Now, the reason I chose blue for these is because in an exercise that was, or in an activity that was planned later, they're currently all plugged into GND sockets. But to change the brightness of the light emitting diodes using a program, you can actually plug them into these D/A sockets and use a slightly different script to make these brighter and dimmer in order to figure out how the actual distance something is away from these infrared. All right.
Andy, I have a question for you. Maybe if it's further along, please stop me.
Okay.
I noticed that P20 and P21 are illuminated based on reading and confirming that, let's say, there's nothing in front of the object. And if something gets in front of the object, those two LEDs will turn off. Is there a way to read the status of P20 and P21 so that same way, like yesterday, I can add a tone so that I've got a left tone and a right tone, but it's if that's open versus closed. Does that make sense?
It does. Yeah, you're a little ahead of us.
No problem.
So let's hold that question.
No problem.
And please do remind me, because it's kind of important to answer that. But we need to talk about a few other things leading up to it, I think, or at least I can't figure out a way to give an answer that works well for everybody at the moment, but we're going to come back around to that. All right, so let's real quick. No, I think we better take a 5-minute break first. It's 4 o'clock or 4:01. So let's all come back by 4:06, and then we'll test and troubleshoot our infrared LED circuit. I was going to try to sprint through it before the break, but I think we'd rather just take a break, especially if the troubleshooting goes long. So let's take a break and come back and run the code. We'll see you. We'll actually make it 4:07 Pacific, 5:07 Mountain, 6:07 Central, or 7:07 Eastern. Come on back by then, and we will resume with testing and troubleshooting our infrared circuit.
But I am leaving the recording on.
Thank you, Stephanie. Yes, so
If you're staying, can I ask you a question about reading a digital pin?
yeah, okay, so I'm thinking about that, and there are several ways to do it. One way is that you can jumper one of these IO pins. I actually am going to need to look this up to before I answer you, actually. So
Are P20 and P21
they're
functionally,
outputs.
so they're just functionally
They're actually D to A outputs. So
Okay.
essentially, P20 is right below D to A1, pardon me, D to A0. And P21 is right below D to A1. And so if you set voltages on D to A0 and D to A1, these lights will vary in brightness with the voltage going to D to A0 and D to A1.
But right now, internally, when you say write digital,
It just turns them on.
correct.
Or off.
They're just
yes.
functionally, they're just LEDs on board versus us going and adding 2 LEDs,
Mhm.
which could be done.
Oh, it totally could be done.
Yeah.
And
But can you do, I mean, I see you've got like for bot, there's write digital. Is there bot read digital?
there is bot read digital, and the thing that I need to go and look up is whether or not I included the read digital, but don't affect the pin's output state. See,
Well,
you
if
know,
you're writing,
the quick
if
and
you're
dirty way to
writing,
do
it's
it is
stable.
basically, it's already turning the P20 light on if it's getting a high signal on P2. So the short answer is, don't try to read P20 and P21, read P2. And then do something about P2 instead, because what's going to happen in this script is that it reads P2, and if P2 is getting a low signal, okay,
Zero.
so my memory is a little bit hazy. I don't remember whether it directly. I believe these like stay on. I better look at the code here. Okay, so here's the detect. I believe the detect just. I don't know if the detect inverts. I don't think it does. I think we try to leave it all as simple and unadorned as possible. So I believe that these lights are going to stay on. We're going to find out in just a minute.
Can I store the state?
You
as a
are
variable-
storing the
as a
state in this
variable?
test script. Yeah, a variable IRL. So you can check IRL to find out
So
if it's a 1 or a 0.
so just
and
do
then-
a print, just print IRL.
Yes. So here we go.
I'm trying it.
You can tell me whether it stays on or off.
Ooh, that works. Okay. Within serial, that's fine because I can also do a display and I can move a pixel or do whatever. By just reading my IRL and my IRR, I'm getting my 1s and 0s. And then I can say if IRL equals X, do this. If IRR equals X, do that. So I can add in that my tones are conditional.
Yes.
Okay. Thank you for your, that's just me showing, I'm just unfamiliar with reading.
Well, there's more
This
to
way.
it. I didn't get a chance to look it up because there are 2 versions of reading. One changes the direction of the pin to input before it reads. The other just reads but leaves it alone. So you can actually read whether or not some other part of your program is sending a high or a low. I don't know if I included that one or not. And the way to find out is going to be to.
I
take a
could do a
look at
bot, I could do a bot 20 dot read under digital IRL. But like you said, if it flip flops it, well, then
Yeah, I mean,
I'll see
basically,
my
you don't want to
statement.
kill your indicator, or not kill your indicator, but you don't want to make your indicator do something other than what it was doing. All right, so let's see here about read digital.
So read digital,
there's
just
read
gets,
digital.
it just gets the state, which is fun.
Well, except that my guess would be that internally it also changes the IO pin from output to input, which means you would get some flicker. And you would also.
Oh, because, okay, so the propeller will have to flip it in order to change. Well, that's fine. I can store it as a variable if I wanted and just constantly monitor my variable.
Yeah, it's that's much better than
Okay, I didn't think about what the propeller was doing, that it is an output.
see, the propeller has
Input.
it has 2 different flavors of read digital, but my best guess is that I only did the flavor of read digital that makes the IO pin an input.
Okay.
and it's reading from an external circuit because it would get confusing if we added in the thing to read what some other part of the multi-core program is doing when we aren't actually specifically using multi-core here as a set of lessons. So yeah, that's why I didn't put that in. I should say we, because that this was a joint project between us and cyber.org, but I was one of the two main authors of the firmware. So I'm just kind of relating my thinking to, about what I was thinking when we discussed it. And
Do you have, while you're there for tone, is there a tone off, tone null, tone none?
well, this tone always has a time.
It is time 0.
I mean, yeah, sometimes time -1 is go indefinitely. I need to check that too.
No problem. That's more technical.
Let's see, Cyberbot.
What I'm going to do is I'm going to define 3 different tones then. I'll have a left tone, right tone, and a no tone. And I'll just set my tone because it'll still look for those parameters at 4000 0 or 4000 and then -1. And I'll tell you what happens.
Okay. See, I'm looking for tone here. Time.io would be tone. There it is.
And
You know what?
frequency.
Yeah, I don't specifically have in here to go indefinitely. What I have is basically to play the tone for a certain amount of time. And notice that you can go up to a rather high frequency.
Well, but it says millisecond duration
Yes.
is 0 is valid. So 0 should be that I can set that to 20,000, but comma 0 means just the duration is not at all.
Yeah, in practice, the duration of 0 is just a few clock ticks.
Well, I'll set my tone to a very audible tone and my duration to be doodly squat, and I'll tell you what happens here in a sec.
Okay, thank you. All right, let's see. Need to find where I was. Let's get restarted with our troubleshooting here. Okay, so the first step for some of you may be to check for your module. So like, for example, I got a frowny face when I tried to run this script, which is on the next slide. I'll be pasting it in a minute. And I got a frowny face, and hitting load save, see that I don't have my my script. So I'm just going to copy this code and then go to load save or browse for a file and open up something like Center Servos from downloads. And then paste over Center Servos, because Center Servos, hitting load save, because it's a hex file, and I had put in the Cyberbot Pi previously, as we all did, it's still there. So that's a quick and dirty way to do it without having to import, go through the steps of importing again. So I'll go ahead and copy the link to you. I apologize to those of you who I've missed some direct messages. If you still want to, if you want to wait for an answer, I'll try to go back and check your direct messages. If you want to get an answer sooner, go ahead just chime in by unmuting yourself. So I just pasted in the link that has the test code that we'll use. And it's all the way at the bottom of the page. So I'll copy that, paste it in. And then that is what I also pasted in here already. And let's see here. So we can go ahead and flash this. Yes, it is. So these lights are both on right now. The P20, the P20 and P21 lights are both on. And what I want you to do is check by putting your hand in front of each infrared light emitting diode and verify that when you do that, the light goes out. So this is the right side of the robot, closer to the lights. And so we want the right light, the P21 light, to go out when we put our hand in front of the light emitting diode. And it should actually go out with your hand some distance away. Like, see how it's still going out, even though my hand's about 6 inches away from the front of the robot. Okay, and then repeat that for the left. This is the robot's left side here. And we want the left light to go out when that happens.
My P20 light is not on. What might I be not doing
Your
correctly?
P20 light is not on. Let's see, P20 is the right side. That's this group. So generally there's going to be a circuit error. And so what I would do is go through, first of all, make sure that no wires are touching each other. Make sure that you've got one empty socket down below here, and then your red, black, red resistor is going to plug into P1. And then your red, red, brown resistor should plug into P2, the P1 socket and the P2 socket. Double check those. Then follow your resistor that's in P1 from P1 to the other end, and make sure that it is the second row from the bottom. Not the first, but the second row from the bottom. So 1, 2. Then you'll have verified, and then also make sure, like, pull up a little bit and push in a little bit for both ends of that resistor. Then repeat the same thing for the P2 resistor. Make sure that it's well connected to P2, that it's red, red, brown, and that it's going into the third row up here. So this is where the red, red, brown goes, is the third row up.
What, I got a frown face when I put this in.
Okay, so Marcel, Marcel, hit the load save button and
Mhm.
make sure that you can see your cyberbot.py module.
I see that. Yes, I see it.
Oh, okay, but you still got a frowny face.
Yes.
Let me repaste that code.
For what it's worth, Andy,
Yes.
today, and I've had no Chrome updates. Today, I'm getting more of those 504 fails.
Okay.
If it's a frowny face followed by error or line number, that's different, but
Yeah, so Marcel, hit open serial.
just got another one.
Open serial. It says that line 5 in module
Okay.
type error function takes three positional arguments, but 4 were given.
Ah, so you probably have a 22 in the position I'm highlighting right now.
Okay, can you put that code in the chat, please?
Yes. Yeah, what you're doing is continuing to use the code that I incorrectly gave you on Monday. I apologize for that. Okay, so back to the problem of the P. Was it the P20 light or the P21 light that was staying off for you?
And then Susan has the P21 doesn't go out.
Okay, so for the P21 not going out, especially check your P1, make sure that you're red, black, red, and not red, black, red, gold, and not some other color combination. One, let's see, why would it not be going out?
Does the orientation of the resistors matter?
No, resistors resist the flow of current regardless of their direction. The orientation of the light emitting diodes matter, which is why I made a big to-do about which socket to connect the longer of the two pins, because the diode is actually a one-way current valve. You put it in the correct way, current flows through it and it turns on. If you put it in backwards, it's designed to prevent current from passing through that direction. And so one reason it would always stay on is if you had this light emitting diode in backwards with the longer pin closer to the black sockets below it. So if I plug it in backwards like that, see how I put my hand in front of it, but the light doesn't go out? So then I check it and, oh, goodness sakes, look at that. The longer pin was in the bottom instead of the top. So then I turn it around, bend the pins and put it back in. And of course, I'm not supposed to be doing this with the power on, but forgive me, everyone. And now it's working. In general, there's going to be a circuit error of some sort or something that's not plugged in properly. Those are the two.
What if the 2K and the 220 were reversed? Would it be restrictive enough that it's, just checking to make sure that positionally the 2K and the 220 ohm resistors?
So
We're not
if
switched.
the 220 and the 2K were swapped, that would mean that this light would be really bright.
Yeah.
And so if you're facing a wall that's a few feet away, you might actually see the light stay on all the time, assuming that everything else is working, the P21 light. So the best thing to do is going to be to just double check your circuit. I will go ahead and paste this in since it's nice and zoomed in for us, or possibly leave it here for just a little bit. Gently pull out each part from its socket and push it back in a little bit, just to make sure that there's electrical connections. Okay, so I'm pasting in this slide for anybody who's trying to troubleshoot their bot. Oh, actually, that went to Alan because you direct messaged me something.
Sorry.
That's okay. Paste. Okay, now it's to everybody. And Alan gets 2 copies.
It's twice as much work.
Hey, Andy,
Yes.
only my P20 light is on, my P21 is not on.
Okay, so your P21 light is not on. So that is this right side. this right side setup here. And chances are that it's detecting nonstop. Alan just asked if we were to swap the red, black, red, which is lower in the picture, with the red, red, brown, then it could be looking a long ways away. Or if you have something that's 6 or 8 inches away, if you move it out of the way, that might allow it to turn on. Yeah, always low. Check that the ends of the resistors go into P1 and P2.
I see my problem. I crossed the resistors. I need to redo my resistors.
Oh, so they were swapped?
Yes.
Okay, yeah, so the red, red, brown, the 220 ohm is a very small resistor. And when you put a small resistor in series with a light, it resists the current through very little. And so you have a very bright light, which means it's farsighted, which means that it's shining the light very brightly, and this will be much more sensitive to things that are far away. Okay, so one thing we can do also is do a little bit of tech support afterwards. How many of you, can I get some thumbs up? How many of you have got your system tested and ready to roll? 1 thumb, 2, 3, half working, 4. Okay, so WB, can you help me? Justin, thank you, 5. WB, is your half that's not working that P21 half?
Yes, yeah.
Okay.
Oh, my.
And refresh my memory, is it staying on or staying off?
Here, I'll turn on my camera for a minute. It's staying off.
Okay,
Sorry.
can you go ahead and just show it to me in your camera?
Yeah. I also have my daughter in here helping me because she's done a little breadboard, but neither of us could figure it out. So
Okay.
here, let me take my camera for a minute. Okay. So is that
That's pretty good. Yeah, so can you go, I want to try to emphasize the, let's see, I'll unshare my screen. Stop share. Okay.
So,
Okay, so I see a resistor
Yeah.
that looks like it might be going into, this may be the angle, but check your 220 ohm resistor. How many rows up is that going?
220 is which color?
Red, 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 brown. Is it going to the 4th row up?
Red, red, brown is going to the 3rd row up because the black wire is in the 4th. Do
Okay,
I have those?
so, now let's start with your IR receiver. Is your IR receiver in the 2nd, 3rd, wait a minute. I'm sorry, the 3rd, 4th, and 5th rows? Bottom row is
Yes.
number 1. Okay.
Yeah.
Okay, so your 220, your red, or I'm sorry, your 2K, your red, black, red should be in the 2nd row. Your
Yes.
red, red,
Mhm.
brown, I misspoke, should be in the 3rd row. Is it in the 3rd row?
Yep, it's in the 3rd row.
Okay, then the black wire that goes to ground should be in the 4th row.
I
Yep.
think I see it.
Oh, what is it, Alan?
Okay, if you move your robot so that we can see all of your pins closest to cyber.org, so you can see the numbers. Now, yeah, it doesn't, you don't have
Hold
to
on.
come in, but there you go. So you're in pin 15 and 14. And you
Yes.
should be in 14 and 13, or
Oh,
you'll have to change your code.
Oh, okay, okay, let me give that a shot.
So move, yeah, each one down. That way your 2K and your 220s are in the right spot.
Okay.
Power it
I was
down and
completely on
power
the
it-
wrong side.
Yeah, move your slider to 0 and then back to 1. And then maybe, no, that's good. The
Okay.
The
one that's
switch.
your power switch.
Oh,
To your,
But I don't.
Oh, this.
Yep. and then restart it.
Oh, no,
And then
no, I have
power
no
your
lights.
lights.
Oh, my hand was in front of one of them. No, I still only have the one.
Okay, that is the left light still. So
Yeah.
there must
Maybe,
be.
maybe I just have a bad resistor or something. But if everything's right, I can keep fidgeting with it, but
Oh,
if you
what
think
the
it's all
hell?
right.
Okay, so yeah, I guess the one thing I want to check here is with your red, brown at the top. Is that going into the 5th row down?
1, 2. No, it's going into the, wait a minute. From this side over, it's
Yes.
going 1, 2, 3. It's in the 4th one.
Okay, put it in the 5th one.
This one.
Is
Oh,
it
as soon
black?
as I took it out, the other one lit up. So
Okay,
hold on. Yes. Okay. Well, yep. Oh,
awesome.
right. Okay. I think we're good. Thank
Okay,
you.
certainly. All right, now how do I unpin here?
Andy,
Unpin. Yes.
so when I switched the right resistor in there,
Uh,
but the P21 light only comes on if I put my hand on it and it flashes. If I take my hand away, it does not stay on.
okay, can you unmute your video and show me your screen?
Yeah.
Can you?
So when I touch this resistor, you see how it flashes, or I don't know if you can see it.
No, but if you're touching it and it flashes, unplug it and plug it all the way in, and also check to make sure that resistor is going into P1.
No, it's not.
Unplug each end one at a time, and then plug it all the way back in.
Turn it off.
So what I'm thinking is that you've got a tenuous electrical connection, and those usually happen when you're not plugged all the way in.
All right.
Okay, so that one's going to go into P1 and then the 2nd row. Closer to
It's
the,
actually the one that was in P2.
okay, so P2 is going to go to the 3rd row. 3rd row to P2, and that's red, brown.
Yes.
And then
Let's see.
2nd row to P1. And generally, yeah, it's something that's either not plugged in or isn't quite plugged into the right socket.
No, I just lost all of them. I don't have no lights now. Yeah, nothing.
All right, well,
We'll troubleshoot it at the end, I guess.
that sounds good. Yeah, because we can reconvene with you, Marcel.
He knows where to find you, Marcel.
I know where that guy works. Okay.
And it's not contingent upon the lights working or not, right?
Well, I mean, the lights need to work. No, they really need to work.
No, his employment status. Is
Oh
what-
yeah, no.
Okay.
All right. So now that we've got that test script running, I'm going to paste you a page with another script. Oh, you probably can't see my slides yet, huh? Remove pin. Share screen. Okay. So, chat. Okay, so this is the link with the test script. And we'll go here. And I'll also paste it in for you. Because it doesn't look too long for the chat. So after pasting it in, make sure your 3-position switch, your PWR or power switch, make sure it's in position 1 so it doesn't run away from you. And once you make sure it's in position 1, hit flash. I guess that is another thing, is if you had your switch in position 0, I don't know what it would do. I'd like to think that it wouldn't do any lights on or off. Marcel, you may have accidentally moved it to position 0. Okay, so once you've got this going, now don't do this next thing I'm going to do. I'm going to adjust my code so that it goes very slowly by making all these 75s, 20s, and 15s. Okay, so you can go ahead and flash it unchanged. I'm flashing mine just so that hopefully it'll demo okay on the screen here. Okay, so then the box tends to make a pretty good obstacle. Although it's visible quite a ways out, so I'm going to use my hand, which is a little less reflective of infrared. Oh boy. I think my 15 and 20 were reversed in my script. All right. So mine is just a slow motion version of what you'll be seeing. You can unplug your microbits and put it on the ground if you like. Okay, so here I am going forward. And then when I put my hand in front of the right detector, it turns until it can see its way clear to continue going forward. And then if I put my hand in front of the left detector, likewise. So there we're turning away from the right, turning away from the left. See if I can get that where I'm not. And then if you cover both of them, it's going to back up. I need to adjust my backup and the script. Let's see. The right wheel is faster. So try that on the floor at full speed and then come on back and let me know how it worked for you. I'm going to make a change here and try something. See if we can get some following. No, that didn't work at all.
I sent another private, so change yours back to
There we
every
go.
done, if you wish.
But can you see the way I've got mine sort of following my hand? Okay, so how are we doing? Did we get some ability to detect an obstacle and turn away from it? Okay, so I've got a yes from Alan. How about from some of you others? I know Marcel's still working on his. Randy, working for you. Good job. Maybe everybody left and they're chasing their robots.
Mine, dude, my cat.
Oh, the question was, did it work for you? Or what, was it able to turn away from obstacles you presented it? And we have a puppy chasing a robot. Careful, you might end up with, oh, make sure he doesn't like eat the parts. Put it out of his reach after you're done. Some of those parts could be very damaging to puppy stomachs.
Yeah, it could become a $10,000 robot.
Yeah, indeed, very quickly. Yes, WB, great job. After a tough start. Oh, goodness. Let's see here. Okay, so the question, I see a question that's how to adjust the curving, and that is something that we discussed on Monday, but deserves a revisit. If you have one wheel that turns a little faster than the other, it's usually best to slow down the faster wheel. So I'll switch and let's test and see which direction mine goes. Actually, mine's going nice and straight. One thing you can do is just use 200s instead of 75s, and that'll straighten it out. But like, let's say that your robot's turning to the right. So this is to the right. That means you want to slow down this left wheel because it's going faster to make it turn to the right. And so slowing it down would involve in the code taking the left wheel and reducing that speed to maybe something like 60 if it's curving to the right. And then if it's curving to the left, that would mean that this right wheel is turning faster. So you'd want to instead reduce the right wheel speed. And 60 would be like a hunt and peck thing, and you'll probably need to try a couple times until you get it dialed in. And that's something that we'll want your students to do too. Okay, so what do you think? Is that kind of a neat application? Using infrared as little flashlights to see objects in front of you. All right. I'll let, so what I'd like to do is,
I have some questions, actually. A bunch of stuff has popped up.
oh, okay. Let's go ahead with the questions. Stephanie?
Yeah, I'm looking.
Okay.
Oh, how to adjust it when it curves.
Oh, that's what I was just talking about.
Okay,
Is to slow down the faster wheel.
that was, okay, there was a lot of questions I was scrolling through.
Yeah.
Or comments. Go ahead.
Okay, well, Stephanie, like everybody else, just unmute yourself when you find a question that needs to be asked.
Sure.
Okay, so real quickly, we've got some awesome applications that use a second microbit. One of them is from the cybersecurity sequence. shut the tabs to the right down. Okay, so you can click either cybersecurity here or navigation control from a keyboard or right here, either way. And it'll take you to the front page of that chapter. And it looks kind of like this. Let's see. Can everybody see okay? Okay, so what we have here is a 1 microbit that's connected to the computer, and then a whole classroom full of microbit powered Cyberbot robots. And so when Ken here types into the terminal, it says enter left speed, he types -100, -100, enter right speed, -100, enter milliseconds to run, 350. And then it creates something called a dictionary, which there's a lesson on that gives us a list of key value pairs, and it sends, and the microbit that's connected to the computer here sends that out over the radio.
That's cool.
And all the rest of the Cyberbot radios are tuned into the same channel. So every speed and runtime command that Ken puts into the computer, the whole classroom follows. Now, why is this called a cybersecurity activity? The answer is because this is on an open radio channel currently. So any student could basically hack this connection and take control of the robots, which is a very common thing done in industrial espionage, industrial and military espionage. And so it's kind of a thing that we want people to understand and be aware of. But it's also just a fun application to do as a purely robotics thing.
That's basically the way, like at the Olympics, they had the introduction with, is it 1,000 drones that were all?
Oh yeah, I'm glad nobody hacked into that.
Yeah, that could have been fun.
That would have been horrible. Oh geez. Yeah, drone propellers are super, super dangerous. For any of you, if you ever go to a drone exposition, make sure you and your children stay well away from the drones. If they get close to you, be ready to get out of the way, because they have sharp propellers that can do a lot of damage in an instant. Okay, so here's another one. In this one, we're using that same unprotected radio channel, but this time where we have a microbit, instead of being plugged into a computer, it's plugged into a battery pack that comes with it. If you get a microbit Go kit. And there's several things going on here. The first is, as we tilt it, since there's an accelerometer, which is essentially a tilt sensor that's inside the microbit, it's actually showing a clock hand to indicate which way, if you put a ball bearing on top of the microbit, or a plastic ball would be more appropriate, which way it would roll off. And you can see that both on this microbit and on the robot. So you can actually, try this test out just with 2 microbits. And, but it's really fun to be able to tilt the microbit to the left and have the bot turn left, and then tilt the microbit away from you, have it go forward, tilt right, tilt forward, etc. I'll play that one more time. So at the very beginning here, he's tilting the microbit away from him so that the ball would drop down like that. We can see that that's what's seen here, and that's the straight ahead motion. And then that's tilting to the right, tilting to the left more and more and more, tilting forward again. So there's a lot of really nice control. The kids love to drive these around. You can put them on a maze and they'll have fun for, some time with that. Now, these are both good standalone robotics activities, but they also feed into cybersecurity as an application to protect using cybersecurity techniques. So cybersecurity can be approached as part of the Cyberbot. You'll notice that there are a number of cybersecurity lessons in the bookshelf here. I actually, the technical word is bookshelf. I refer to this as a book, and then each of these are chapters. But in web speak, this is a bookshelf. So pardon me for using those two interchangeably. And then these are all in, according to the web, they're books. But according to, studying your students, they're chapters, and this is a book. So let's see, what was I going to say? Yes. So software setup, writing microbit programs, adding modules. At that point, you're ready to jump down and build your robot. But there's more computer science lessons, and these computer science lessons feed into the scripting stuff that happens for the cybersecurity. There's using the terminal to talk to your microbit. Dictionary primer, that's the kind of lists that go back and forth over the internet whenever you do a search. The exception handling, that's the kind of thing in a web page. If it's programmed properly, it won't stall on you. But if you've ever had a web page stall on you, it's probably because there was improper exception handling. And that's something that can be exploited by hackers. Strings and characters primers, they have a lot to do with being able to encrypt stuff. And so then we go through our basic robotics lessons. Here we have sound, navigation, circuits, etc. But once we go through visible light and infrared light, the next one that comes up is basic radio communication. Then there's radio data, keyboard control. You saw the video of that. Radio control. You saw the video of that. And so we do these two things to give something worth protecting that's robotic. And then we go into how to encrypt data, a sniffing attack, which would be just looking at the data to gain information to one's advantage, and how to prevent it, how to defend against it. Then there's also brute force, which is essentially trying to get the secret code that allows you to figure out what the encrypted data really means. And this is for older boards. So these things are done with microbits, but then also we have robotic. So there's microbit only applications that can be protected, and then there's also robotic applications that can be protected. And so what we have is two ways of doing this. We have a way where it's all incorporated into the Cyberbot lessons, but we also have but we also have one where it's just the cybersecurity related lessons on their own, done only with the microbit. And that's in the cybersecurity tutorial series. And you'll see both of those in learn.parallax.com. When you scroll down to Python, you'll see Cyberbot and cybersecurity. And so those are the two versions of cybersecurity. And if you want to learn more about that, here is 6 hours of YouTube recorded workshop that focuses on the cybersecurity only with 2 microbits. And given what you now know about the robots, it's not a big step to watch this and go through the lessons that are there, and then you can basically step right in and expand it to using the robots. So I'll go ahead and paste the main link for these. It's got links to videos 1, 2, and 3. And then this actually is also the YouTube video, like the second pair, or the second of 2 sessions, or the second of 2 workshops. So well, I'll just paste both of these in. One is a playlist and the other is a simple links for session 1, session 2, and session 3. So you can learn all about the cybersecurity stuff through that. And since it's on YouTube, you can put it on fast forward and run through it at your leisure. There's a bunch of slides that I'm going to skip over, and then we'll go back to some of them if time permits. I guess I will just say, okay, so here's an excerpt from the dictionary tutorial, and that's again the way things are arranged when you do an internet search. It gets put into key value pairs before it's transmitted across the internet. Some other things that might be of interest would be after learning about strings, we learn very basic fundamental encryptions first, like this is the Caesar cipher. And basically, if you wanted to transmit the E from hello, you'd start with the E. And if your encryption key is the number 5, you would simply count over 5 letters. And instead of transmitting the letter E, you transmit the letter J. And so that's kind of like a first level of encryption in the cybersecurity series. And that all gets built into how to use the radio to, and this is a chat example. And the chat example is another one for the purely microbit to have something to protect with encryption. And lots of good material there. And I can also answer some questions about it after the workshop today. There's also some great projects. Here's the QTI line follower. And down at the bottom here, we have a YouTube video. Can everybody see that okay?
QTI is an add-on bit, correct?
Yes. So for projects, thanks for asking that, Alan. Yeah, for projects, if we look at the Cyberbot tutorial series here, this is all with the stock robot, with the exception that some of these require a second or even in some cases third microbit. I think brute force requires 3. Then down below at the very bottom here, we have projects, and these are optional add-ons, but they also come with the class packs. And one is the QTI line follower. Another is the ping on a turret, so an ultrasonic sensor on a turret to scan a range of distances and objects. And then our TV remote, since we use TV remotes for infrared detection, it's not a far cry to say, hey, let's use the TV remote to control the robot. And so again, this first one was the is that rendering okay for you folks?
Oh, yeah.
Okay. And these are the high-speed servos you were asking about, Marcel. As you can see, it really moves fast. So here's the TV remote. There's a cute video of using the TV remote to control it. And then this is kind of a must-see. And again, these are optional add-ons that I'm talking about now. And they also, like I said, they come with the class packs. They're 12 packs of robots plus all these extra sensors for the projects section. Okay. Electronics lessons, I talked about that and that there's an upcoming workshop. Educational resources. So slide 180, and this will kind of move up and down a little bit as the slideshow gets tuned. But if you look for this has a nice table with links to some of the commonly used resources available. There's also the student lessons are at learn.parallax.com, and then the teacher resources are in the educators tab. See here. So if we go to, I want to loop back around to that. Oh yeah, this is microbit only for middle school and younger teachers. It's a repeat of an earlier one, as was the make it, code it links. This was when we did the step counter at the beginning. This is a link to the documentation for the microbit. Whenever you look at an example program, if you're curious about if it's a microbit only example program, this is a place to look. And then cyber.org. Cyber.org has a number of resources that you can use. They cast a much wider net than Parallax emphasizes robotics, electronics, and computer science. Cyber.org and cybersecurity now. Cyber.org has a cybersecurity emphasis, but they also have cyber literacy 1 and 2, and that's where they use the Cyberbot, and they have at your own pace courses that you can take, and it's kind of a nice alternate angle to look at uses of the Cyberbot robot. And again, cyber literacy 1 and 2 is where they use the Cyberbot in their curricula. And you can sign up for cyber.org as long as you're a teacher in the United States. Then you can use the sign up button. And then after that, you can log in to access their curricular resources. And then they have a workshop and events page as well. They're a very important resource. Product-wise, if you want to purchase and equip your classroom with the Cyberbot robot, if you go to this web page, that will show you the price breakdown of just the Cyberbot. So, for example, if you're wanting to equip a class with 20 or more Cyberbots, instead of $279 per bot, which would be the 1 to 9 price, you'd be looking at $251 per bot instead. And there are also, sorry, got ahead of myself there. Then there are class packs, which have 12 sets of robots. So there's 12 robots, but you also have enough rechargeable batteries and a battery recharger to keep those robots going. The QTI line follower kit, the ping turret, and the TV remote, so that you can do all the regular lessons plus all the projects. If you already have a Bobot robot or an Arduino Shield bot, there are ways to convert those to a Cyberbot robot, especially with the Arduino robot. I usually just disconnect the blue board that holds the Arduino on it and connect the black board and its 4 screws and 2 servo cables, and then you're off and running. With the Bobot robot, you also need a battery pack, because the Bobot robot has a 4-cell pack, but the ShieldBot requires the Cyberbot requires a 5-cell pack. Let's see. If to learn more about the Cyberbot, you can go to www.parallax.com/cyberbot. Whoops. I don't know where I went just then. / Okay. So now we are at the Cyberbot page, and this has a shopping link, information, links to the tutorial series, both at the Parallax site and at Cyberbot and to the cyber.org site, and then an explanation of the educator support. upcoming workshops we talked about, again, there's an electronics workshop in late October. And then real quick, I know I'm keeping you over again. Sorry about that. I just wanted to loop back to the educator resources and show you the Parallax. So if we go to learn.parallax.com, actually, I'm just going to start right here at learn.parallax.com. You can click the Educators tab. And then go to Cyberbot resources. We have some resources up front that if it doesn't answer any questions that are assigned to the students, like the standards matrix, you can just open without logging in. And then we've got scope and sequence, the standards matrix for alignments, and this slideshow is linked in there. And then there's some few words about teaching and strategy guides. And then there's this locked off area. And what you'll want to do to get to the worksheets and questions and answers is to basically hit this logged in button. And after some discussion during the previous workshop, we also added a login link right here. So you can click educators and then log in. And then when you go to Cyberbot resources, instead of seeing this locked off, it would be as though you had already logged in. I'm going to take this off screen while I put in my credentials. Okay. So now I am logged in as a teacher. And when I go back to learn.parallax.com, educators, Cyberbot resources, and scroll to the bottom, here is the assessment materials with warnings not to redistribute those to the students. And so, for example, if we wanted to look at touch navigation, I just downloaded it and am opening and am unzipping. And after unzipping this zip file that I downloaded, we have a folder, and it's difficult to see, but there's a PDF and a RTF document that have the same thing. And I just double click the PDF document, and that brings us to a worksheet that you can print for your students as, you know, either homework or quiz or however you want to use it. And then we have the answers below the worksheet. So that's an example of some of the, and so careful, make sure to only print pages that are in black ink and then not print the ones that are in red ink. And then we have a nice little scoring rubric at the end here. And so that is an example of some of the resources that you can get through learn.parallax.com, which for your homework, that was what we had you, now I lost the page where, So anyway, the assessment material, we have many downloads to accompany the many chapters that are there. Last but not least, we have a slide with, we were in support, talked about the upcoming courses. We also have an educator hotline. Education@parallax.com is a super useful email. I strongly recommend that. Educator hotline, 8 to 5 p.m. Pacific time. Email, education@parallax.com. You'll definitely get somebody's attention that way, and we'll pick the right person to respond. Then there's a sales line. We have a discussion forum, Facebook pages. That's all here on this slide. And cyber.org, our partner and collaborator in this project, thanks you for attending this workshop. And so do we. Thanks for coming, everyone. And with that said, we'll go ahead and conclude this workshop, but everybody is more than free to hang out afterwards so we can get any of your robots that weren't roaming with infrared, and then also just any general questions and answers or possibly talking more about the cybersecurity are all fair game. So thanks again for coming, everyone, and have a great weekend. And Stephanie, we'll have you stop the recording now.